All right, so chapter 4, section 1 is called Apply Triangle Sum Properties. So again, we're going to talk about some properties and theorems that you kind of should already know, but we'll learn how to apply them in this section, and then we're going to dig a little bit deeper into triangles as we move forward. A triangle, by definition, is a figure formed by three segments joining three non-collinear points. Three segments joined by three non-collinear points. The points where these segment meets are called single one is called a vertex, plural is vertices. And the sides are segments. So if you're naming the segment or the sides, you'll always put them in segment form, which means either the two letters or the two letters with a segment over the top, no arrows over the top of them. So the triangle that's there can be called triangle ABC. It can be called triangle BCA. It can be called triangle ACB. Okay, any order of those three letters is fine. The vertices would be A. These are points, so A, B, and C. The sides are A, B, B, C, C, A. God bless you. And those letters don't have to be in that order. They could also be B, A, C, B. God bless you. A, C. They don't need the segment on top of them. That's implied segment, okay? And then obviously the angles that are formed are A, B, and C. These don't share the vertex, so you can use just a single letter. If you're naming a triangle, you will put the triangle symbol in front of it, or you can put the word triangle. But if you just give three letters, you're talking about a plane, not necessarily a triangle. You have to have the symbol or the word. Three types of triangles when classified by sides. A scalene triangle is one in which no two sides are the same. So all three sides have different lengths. An isosceles triangle has at least two sides the same. So it could be two sides or it could be three sides. If it has three sides, then it is also an equilateral. On the bottom, there are some examples of what you could see. So if I'm classifying them based on the sides, then the first one would be scalene because no two sides are the same. The second one, isosceles, at least two congruent sides. The third one is equilateral. Now the third one is equilateral or isosceles, but the better answer is equilateral. So if it's asking you to classify it, you'll give it as equilateral if it has three sides. But an equilateral triangle is always an isosceles triangle. By definition, isosceles is at least two congruent sides. So equilateral is always isosceles. And isosceles is sometimes equilateral. How about scalene? Can scalene also be isosceles? No. So a scalene would never be isosceles. A scalene would never be equilateral. Yep.
Wait, why can isosceles be sometimes?
Because isosceles says at least two congruent sides, which means it can be two congruent sides or it can be three congruent sides. If it's just two, then it's only isosceles. But if it's all three, then it's isosceles and equilateral. But again, if you're classifying it, all three sides are the same, the best answer there is equilateral. Okay, second way to classify a triangle is by its angles. There's four ways to classify by angles. Acute means all the angles are less than 90 degrees. Obtuse means one angle is greater than 90 degrees. Right means one angle is 90 degrees. And equiangular means all the angles are equal. At the bottom, there are examples of each one. So acute triangle, notice that all three of these angles are less than 90 degrees. That's acute. A right angle has the one right angle and it will be marked, or you will see something about it being perpendicular. The obtuse triangle has one angle that is larger than 90 degrees, and the equiangular, has three angles marked as congruent. It could be that way, or it could say something like angle A equals angle B equals angle C, or you could see an actual measure where they're all the same.
So it's impossible.
Okay, first theorem that has a name in this chapter is called the Triangle Sum Theorem, and it says something you all have known for a very long time. The sum of the measures of the interior angles of a triangle is 180 degrees. That's called the Triangle Sum Theorem. So you can use that name, or you can write out some of the angles in a triangle is 180 degrees. I don't care. They both mean the same thing. Exterior angle theorem says the measure of an exterior angle of a triangle equals the sum of the measures of the two remote or non-adjacent interior angles. So remote or non-adjacent, if you look at this diagram that's here, the angle that you're looking for the measure is angle 1. Adjacent would be this angle in here, right? So non-adjacent or remote are B and A. And what this says is that angle 1 equals the sum of angle A and angle B. Think about why this is true. What do we know about, I'm actually going to give this one a number. I'm going to say this is angle 2. What do we know about angle 1 and angle 2? Aside from them, they are adjacent, but what else? They're a linear pair, which means they're supplementary, right? So if I wanted to prove this, I could actually say angle 1 plus angle 2 equals 180. And that's the linear pair postulate. What else do I know about the angles in this triangle?
Angle A and angle B are same side, so they're supplementary.
So they're only same side if they have the parallel lines. You don't have the parallel lines here. So don't forget about those things because they're going to come back in the proofs, but they're not in this one. All three of those angles equal 180, right? So angle A, angle B, and angle 2 equals 180, and that we just said is the triangle sum theorem. So now what? What's true if both of those equal 180? They equal each other. So I can say angle 1 plus angle 2 equals angle A plus angle B plus angle 2. What would that be? So close. Substitution. Now, if I wanted to get it so that angle 1 equals angle B plus angle A, that's subtraction. So that is how you could prove it. Good news is you don't have to because this exterior angle theorem does it for you. Okay, so again, one that has a name that you can use. If you don't remember the name, then you would write it out. Exterior angle of a triangle equals the sum of the remote interior. Okay, so a corollary is along the lines of like a postulate and a theorem, but a corollary to a theorem is a statement that can be proved easily using the theorem. So once you know a theorem, a corollary is something that you can determine based on that pretty easily, not with a ton of steps. And the corollary to the triangle sum theorem says the acute angles of a right triangle are complementary. Makes sense, right? That's what a corollary is. Something that just makes sense based on what you already know. If I know that all three of these add up to 180, and I know that this is 90 degrees, then all I'd have to do is do 180 minus 90 degrees to know that A and B equal 90 degrees, and if they're 90 degrees, they are complementary. So that's all this means, okay? The corollary to the triangle sum theorem says the acute angles of a right triangle are complementary. If you didn't remember exactly that, you could go through the work that we just did. Add them all up, set them equal to 180. Make C 90 by substitution. Subtract 90 away from both sides, and you'd get A plus B equals 90.
But can't they all be acute?
No. Yeah. But if one of them is right, the other two are complementary.
Oh.
So in order for this to work, that it has to be a right triangle. Questions on that one? So again, if I didn't know it, I could say angle A plus angle B plus angle C equals 180 degrees. And that's the triangle sum theorem. I could say angle C equals 90, and that's given. I could say angle A plus angle B plus 90 equals 180, and that's substitution. And then I could say angle A plus angle B equals 90, and that's subtraction. And then I could say angle A and angle B are complementary. And what's that?
Cool.
Okay. Definition of complementary. So now all these steps can get replaced with the givens and the prove, which would be the corollary to the triangle sum theorem.
Why is angle C equal to 90? Why is that the given?
Because from the diagram, it was marked as a right angle. So I would have had to know that one of the angles were 90 degrees in order for this to work.
You wouldn't have to do all that work.
No, now, so knowing this, I can say angle C equals 90 degrees, and that's given. And I can say angle A and angle B are complementary. And the reason is the corollary to the triangle sum theorem. So these are both right. It's just obviously the second one is a lot less steps. All right, example 1 says state whether the triangle with the two angles having the given measure is acute, right, or obtuse. So what are you going to have to do first? Find that third, God bless you. Find that third angle and then classify them. Go ahead, do it. All right, so if you add 55 and 43 together, you get 98. Subtract that from 180, you get 82, which means that this first one is what? Acute. Second one, 47 and 43 together, that's 90, which means this the other one is not, the missing angle is 90 degrees, which makes this what? Good. C, 80 and 75 is 155. Subtract that from 180, you get 25. This is acute. 33, 33, and 114 makes D, obtuse. And 24, 66, and 90 makes E, right.
So when it's a right angle, you don't subtract it by 180?
Oh, you do. I just know that it's already 180.
Oh, yeah.
Yeah. I just saved myself that step. Questions? Easy stuff so far, yes? We can add things together and subtract them from 180? Yes? Okay, good. All right, find the measure of angle A. So in each diagram, A is obviously in a different location. Let's talk about what we know about these diagrams to figure out what those angles are. So if I look at A, like example A, what do you see going on in this diagram? Because obviously there's two triangles. What kind of angles are here that you've seen before?
Acute.
Yes, acute, but also what? What are these angles called?
Vertical.
Vertical angles. What's true about vertical angles? They're congruent. So although I only know one angle on the right-hand side, I know if I find the third one on the left, I can put it to the right, yes? So if I add up 80 and 50, I get what?
130.
130 subtracted from 180 means that that last angle is 50 degrees. So if this is 50 degrees, this is 50 degrees. You with me so far?
Yes.
Which means that last angle has to be 80 degrees. So vertical angles are probably like the thing that's going to continue throughout the rest of geometry. Like they never go away.
Can't you also do the exterior angles theorem?
So the exterior angles theorem tells you that this angle, that would be my exterior angle, is the sum of these two. So this would be 130. These, or actually you could go the other way around. Then this would be the sum of these two. You could do it that way too. There's a lot of different stuff on here. There's linear pair if you pull that exterior angle into play. There's a lot of different stuff. Okay, B. Now I've got my angle, my triangle at the top, bottom, completely separate, but what's connecting them? There's congruent angles, right? So on the bottom triangle, if I've got a 60 and a 40, what's left for this angle? 80, which means that this is 80 degrees, which means angle A is 60 degrees. Still good, yes? Feeling pretty smart today, folks? Good. Okay, last one. Again, congruent angles, right? So on the right triangle, I've got 30 and 110. Add those together, you get 140. Subtract that from 180. 40, which means this is 40, which means A is 110. Questions on any of those? Okay, example 3 says find the measure of angle A for part D. How do I do it?
It's a linear pair. You add. You use it 180 from 80, and that here.
So the linear pair you could use is this one. Yeah, you could do it that way. You could say that they add up to 180, which makes this 60, right? And then the three of these have to be 180. So you could add 60 and 80, and I'd get 140. Subtract it from 180. And I get 40. That's one way to do it, right? What's the other way, Michaela? Good. Says 120 is equal to the sum of 80 plus angle A, which means angle A is equal to 40 degrees. So either way, they both work, either way. Okay, the exterior angle tends to be a little bit shorter, but they both work. Which part?
Exterior.
So this is my exterior angle, right? It's equal to the sum of the two non-adjacent angles, which is the unknown and then the 80. Okay, E says in the triangle EFG, the measure of angle G is 100. So this one's 100. And the measure of angle FEH, which is this angle here, is 3 times the measure of angle F. So if I want to call angle F X, I can. This would be 3x. Find the measure of angle F. So what's the relationship between all of those angles? Which is the exterior angle? 3x. The exterior angle equals x plus 100. The sum of the remote interiors, right? So x plus 100. And then, what do? Subtract the x. 2x equals 100. Divide by 2. And x is 50. It's asking for the measure of angle F, which is what we called x. So I can say angle F equals 50 degrees. If it had asked for the measure of angle FEH, what would my answer have been? 50 times 3, 150. Everybody's good? Questions? Overall, anything we talked about today? Okay, so a couple of theorems of corollary, and then obviously some classifications in this section, and then we'll dive a little bit deeper in tomorrow.